They were completely buried by a wall of sediment carried by a lahar which was 14 feet higher than the mean river level or a full foot higher than its worst historical flood, only to be re-exposed by later erosion. At Mount Hood, the main danger does not involve pyroclastic flows, although these have been generated by its past eruptions, but rather long-reaching lahars. Lahars are generated during many eruptions at Mount Hood, due in part to the hot volcanic rock melting portions of its 380 million cubic meters of glacial ice. These lahars can and have swept through several regional rivers, and in fact one area, the Troutdale Airport, is completely built on top of and thus would be once again covered by lahars if lahars of the same severity to what occurred 1,530 years ago. This means that during future eruptions, as many as 7,500 people along hazard rating with additional businesses could be placed at risk. With its last eruption occurring in 1866, it should come as no surprise that Mount Hood is categorized as a very high-threat volcano, ranking as the sixth highest threat volcano in the entirety of the United States. Geologic history: like all other Cascade Range volcanoes, Mount Hood exists due to the subduction of the Juan de Fuca plate underneath the North American plate, triggering partial melting which causes material to rise as magma and occasionally erupt onto the surface, forming a chain of volcanoes. Mount Hood is a fairly old volcano, with its origins being traced all the way back to 500,000 years ago. The first few dozen eruptions occurred not at a central point but rather at a series of spaced vents across a 5-mile wide area, producing ash emissions and emplacing thick andesite lava flows which built the base of the volcano. The best exposure of one of these old lava flows can be found at Lamberson Butte. Eventually, a central vent developed, and a combination of ash-rich and lava-rich eruptions followed, creating overlapping layers of volcanic rock which started to build the stratocone. This gray stratovolcano may have then grown to be as much as 10,800 feet tall. Major collapsed, but then something catastrophic occurred 100,000 years ago. Around that time, a major collapse occurred, destroying the summit and much of the northern flank of the volcano, generating a large-scale debris avalanche. Across the next 70,000 years, moderately explosive eruptions refilled this collapse scar, rebuilding the volcano to its prior height. In the time since, both andesite and dacite lava domes have erupted at Mount Hood's summit, growing the height of the overall volcano, and releasing pyroclastic flows during eruptions due to periodic collapses of the growing dome. Around 5700 BCE, a basaltic andesite cinder cone erupted north of Mount Hood's summit, emplacing the tall Parkdale lava flow. A major eruptive period occurred 1500 years ago, 500 CE 1866 CE eruptions involving two multi-decade-long eruptions. These once again grew lava domes, and their occasional collapse generated pyroclastic flows which traveled as much as 7.5 miles or 12 kilometers away. During this period, a portion of Mount Hood's southern edifice collapsed, forming the modern scar which subsequent eruptions would occur within. Its modern dacite crater rock lava dome formed during a 1781 to 1793 eruption, although this region would erupt again in 1859 and from 1865 to 1866. Mount Hood's eruptions are dominated by eruptive periods, where decades to centuries of frequent eruptions occur only to be followed by centuries to up to more than 10,000 years of no eruptions occurring. It currently appears that Mount Hood is in another quiet period since its last eruption in 1866, but this could unexpectedly change in the future. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube.